Today we're going to be adding and subtracting rational expressions. We're going to review over a little bit of stuff first before we get into the polynomial rational expressions that we're going to have to add and subtract. So on this first problem A, I want to find the least common multiple, which is different than the GCF. All right, least common multiple is the smallest number that I can multiply both of these guys by something and get. So for example, you ask yourself, okay, what is 12 times 2? Can I multiply 18 and get 24? No. Okay. What's 12 times 3?
36.
Can I multiply 18 by something and get 36? Yes. So 36 is going to be my least common multiple because 12 times 3 is 36 and 18 times 2 is 36. Does that make sense?
Yes.
All right. So you're going to have the kind of that mindset today. So for the 4 and the 10, 4 times 2 is, does that work?
No.
No. 4 times 3?
No.
4 times 4?
No.
4 times 5?
Yes.
Yes. So 4 times 5, which is 20. And so what do you have to multiply 10 by to get 20? 2. All right, and then on B, I also have variables. So this is an x cubed, this is an x. So what times x will give me x cubed?
3.
It's squared, right?
What?
X squared times x will give me x cubed. So my LCM is 20x cubed. All right. Number or letter C. This is the 3, this is a 6. So what number am I going to try to make? 6, right?
Yeah.
6. What times 3 will give me 6? 2. Okay. This is an x squared. So what do you have to multiply this guy by? By an x. And so then your LCM is 6x squared. Yeah, you should have done, this is a review. This is leading up to the problems we're doing today. Okay, go down to D. So now we're going to actually have the fractions, which still should be a review. But now we have the fractions that we are trying to find common denominators, which is where the least common multiple comes in. So on D, I have 12 and 18, just like I did over here. So remember, I'm trying to make those guys into 36. So what do you have to multiply 12 by?
3.
3. And if you multiply the bottom of your fraction, you have to multiply the top of your fraction. So 3 times 1 is 3, and then 3 times 12 will be the 36. All right, what are we multiplying 18 by? 2. So if you multiply the bottom, you also have to multiply the top. 5 times 2? 10. When you add up your fractions, the denominator stays the same. You would just add 3 plus 10 and get 13. We are going to skip E, so you can cross that one out. Just the other ones are all paired up with the ones we did before. I don't know. We don't need to do 4 of them. All right, F. If you notice, F has 4x and 10x cubed, 4x and 10x cubed, right? So matches up. What do I need to multiply 4x by to get the,
5x squared.
there you go, 5x squared. What do you have to multiply 10x cubed to on the top and the bottom? So 5x squared times 3 is 15x cubed. Or squared, I'm sorry, squared. That's a square. So 15x squared on top and 20x cubed on bottom plus 7 times 2.
14.
And then 10x cubed times 2. 20x cubed. So you get 20x cubed on bottom. And then on top, can you combine 15x squared plus 14? Nope, so you're just going to write 15x squared plus 14. All right, last one. What am I going to multiply 3x squared by to get Good, 2. And what are you going to multiply 6x by? X. So 2 times 4 is 8. 2 times 3x squared, 6x squared, plus 5x over 6x squared. And can you combine 8 plus 5x squared? Or, sorry, just 5x? No. So 5x plus 8 over 6x squared is your answer. All right, so once again, those two parts right there, they should have been a little bit of a review. Any questions on that? Sweet. All right, go down to A. We're going to take that same concept, and we're going to find the least common multiples with polynomials. So, my first step is going to be to factor. 1 multiplies to give me 9, adds to give me 6. 3 and 3. So I have x plus 3, x plus 3. All right, for the other polynomial, how do you factor x squared minus 9? X plus 3x minus 3. And remember, just like we did up here on the top, we are trying to multiply them by something to get them to be the same. 3 times 12 is 36. 18 times 2 is 36. So when I'm looking at the yellow and the green guys, what does the yellow guy have that the green guy is missing? Right, another x plus 3. Right, there's 2 of them here. That one only has 1. So we are going to multiply this one by x plus 3. All right, they're still not the same though. What does the yellow guy need? Right, that the green guy has in x minus 3. And so now if you're looking at your two polynomials, are they now the exact same thing? Yes, and so once you get them to be the exact same thing, that is your answer. And it doesn't matter the order you write them in.
What does that have to do with no.
It helps you get a common denominator because you're getting the two polynomials to be the same thing. So it's your least common multiple, but in polynomial form.
And you said it doesn't matter what way
No.
you
Okay, on number 2, we have to factor. What do you notice about this guy right here? Right, you can divide a 3 out. So we're going to take a 3 out. X squared plus x minus 6. All right, so it multiplies to give you negative 6, adds to give you 1. Yeah, 3 and a 2. 3 and a 2. Positive 3 minus 2. All right, what can you divide out of the next polynomial? 6. And when you take a 6 out, you're left with x squared minus 7x plus 10. And what two numbers multiply to give you 10? Add to give you negative 7, negative 2, and negative 5. Good. All right, so remember the goal is to get both of these polynomials to be the exact same. So looking at the numbers, what do you have to multiply this one by to make it equal 6?
2.
A 2? And multiply by 2. And what factor is this polynomial missing? X minus 5. So we're also going to multiply by x minus 5. What polynomial is this one missing? X plus 3. And so now if you look at your two polynomials, are they the exact same? Yes, they are. So that is your answer. Bless you. Do you want me to do another one? Are we good on that? Are you sure? Anybody want me to? Just give me the eye, and I'll do another one. Okay. Okay, flip it over. All right, the back is kind of the main type of problems that you're going to see like on a test. So everything that we've done so far is leading up to these problems. We are adding these two fractions. They are they have polynomials in them, and we still need to get a common denominator. First step is going to be to factor. So how do you factor x squared minus 9? Good. X plus 3, x minus 3, plus, and then I have x minus 2, and I have x plus 3. So just like we did on the front, I need a common denominator, so I'm asking myself, okay, what is this guy missing that this guy has? X minus 3. And if you multiply it to the bottom, you also have to multiply it to the top. So on the top, I have 5 plus x minus 2, x minus 3 over x plus 3, x minus 3. All right, now something that people always try to do is they try to cancel out these x minus 3's, but you cannot do that because of this plus 5. So technically this whole thing on top is one whole term together. You can't cancel out the x minus 3's because remember you only can cancel stuff out if everything's being multiplied. Does that make sense? No. Like if when we had x plus 3 over x minus 1, you can't cancel these x's out because that has a plus 3, that has a minus 1, right? They're different. So this is the same thing except we have a plus 5 here. So if you have something that's being added or subtracted, you can't just start like canceling stuff out. All right. Because of the sake of time in this class, and we're kind of running out of time and we still have one more unit we need to get to, I will let you leave your answers like this. All right. It is technically not simplified though. So the more correct way to write them would be to factor all of this out and multiply. All right, so I'm just going to do it for this example to kind of show you how you would simplify this, but on the test, if you get to this point, I will be okay with that. All right, just because of the sake of time. We're going to simplify it. That's what I'm doing right now.
And we're going to add in the bottom?
Yeah. So x times x is x squared, x times negative 3, negative 3x, negative 2 times x, negative 2 times negative 3 is positive 6. And then we are going to add in the plus 5 up here on top.
When are you giving us a review?
Probably next week.
Like Tuesday?
I can give it to Tuesday. And then you just have to combine like terms. So x squared, combine these terms, minus 5x plus 11 over x plus 3, x minus 3. You don't have to multiply the bottom. All right, so like I said, if you want to multiply it out, that is kind of the more correct way to do it. But just because we have to do this quickly, I don't want to spend too much time on this unit. You can leave it like that if you want. All right, jump to number 6. Number 6, can you factor it? No, you can't. What is going to be my least common denominator? Or my least common multiple? 24, very good. So 6 times what will give me 24? 4, so I'm going to multiply the top and the bottom by 4. 8 times what? 3. So 4 times 7 is 28 over 24x minus 15. Good. 5 times 3. So 28 minus 15, 13 over 24x. Some of them are. All right, go to number 7.
Oh my God.
Okay, number 7. Shh.
It's 13 over 24x, right?
Yes. Sorry. For number 7, what two numbers multiply to give you 16, add to give you 10? 8 and 2. Very good. So x plus 8, x plus 2. What multiplies to give you 14, adds to give you 9? 7 and 2. X plus 7, x plus 2. Alright, so looking at this problem, what is this guy missing? The x plus 2. But if you look over here at this fraction, what do you notice that you can do? Cancel them out, right? Do you see how you have an x plus 2 on top and an x plus 2 on bottom? So it makes it a lot easier if you can cancel as opposed to multiplying it back in. Does that make sense? So if we cancel this, now we have x plus 8 over x plus 7 plus 2 over x plus 7. And now we're just going to combine the top. So 8 plus 2. So x plus 10 over x plus 7.
This like really doesn't like I know how to do it, but like it's just like it seems far-fetched. I don't know.
Probably just because it has the x's with it, and so it seems odd. But
So why would you do, if you didn't cancel them out, why would you have chosen x plus 2 instead of x plus 8 if there's no x plus 8 on this side?
It's on the denominator, right?
yeah, yeah. So I'm just worried about the denominator. Number 8. So number 8, what am I going to try to make both of these numbers into? Small. I can go smaller than that. 12. Yeah, 12. So 4 times what will give me 12? 3. So 3 on top and bottom. 6 times what will give me 12? 2. So 2 on the top and the bottom. So I have 9 over 12x plus 4 over 12x. So you get 13 over 12x.
Oh my god, I got it right. I'm gonna cry.
Make sense? Right? Lily. Go to number 9. Alright, x minus 4 over x minus 5 minus 3 over x plus 2, x minus 5. So this one's already factored. Yay, don't have to do that. Right, we got to add in the x plus 2. Or multiplying, I guess would be the better way of saying it. X plus 2. X plus 2. And so now my denominator is x plus 2 times x minus 5. And on top I have x plus 2, x minus 4, minus 3. Once again, I am okay if you want to leave it like this. When you get into either pre-cal, college, algebra, whatever you do, you will have to take it the step farther and multiply everything out. So if you want to multiply it out, x squared minus 4x plus 2x minus 8, and then we still have this minus 3 here. The bottom stays the same. And then just simplify x squared minus 2x minus 11, x plus 2, x minus 5. So you don't have to do those last steps unless you really, really want to.
Wait, so we don't have to combine the bottom?
No. All right, last one, number 10. You can change them to x's if you want. What multiplies to give me 10, adds to give me 7? 5 and 2, x plus 5, x plus 2. What multiplies to give me 5, adds to give me 6? 1 and 5. Oops. So x plus 1, x plus 5. What do you notice on this problem? What can you do? Alright, cancel out the x plus 5s. And so I have x plus 2 minus 3 over x plus 1. And then combine the top, x minus 1 over x plus 1.